Good evening, I'm Tomas Guevara, and this is the channel Rewriting the Reality. Subscribe to this channel to stay at the forefront of the latest discoveries. Last week I watched a video about the birth of the universe according to the scientific community. It begins with what Neil deGrasse Tyson said, that the debate in physics is over. The latest discovery from the James telescope is finally proving the truth, and a crisis in science has emerged. Those who are not prepared to discard outdated theories and consider new possibilities about the true nature of the universe will not have a future in science. The James telescope is opening the door to a new science and could even reveal the infinity of the universe. Thanks to this space telescope, we can see so far back in time that we can almost go back to when space is said to have been born. But something is wrong, either that galaxies would have developed earlier or that the Big Bang theory is wrong. On this channel I have always said that the Big Bang is only an allegory of our birth. The James telescope found more than a dozen galaxies 200 to 300 million years after the Big Bang, which are highly complex, structured, and full of stars in a way that astronomers would only expect from very old galaxies. These discoveries shed light on epochs of the universe that were previously in darkness and put to test the foundations of cosmology. The data provided by this telescope reveal phenomena that are outside the predictions of this current model, and now scientists are facing a disaster. Everyone agreed that the universe began with a Big Bang and has continued to expand since that point. Tyson tells us, "We didn't know the exact age or size of the universe because our estimates could be wrong by a factor of 2, therefore scientists were aware that all the values and sizes of their theories were prone to errors. However, it all fit pretty well into the picture, until the James Webb came along. Now the house of cards of physicists and astronomers is crumbling, and what was long sold to us as truth now appears to be false. Evidence was always lacking. The expansion of the universe and the age of the universe were nothing more than estimates and calculations of mathematical models. However, these theories are considered the central pillars of modern cosmology. The theories offered a reasonably coherent picture of the origin and evolution of the universe, and some of the ideas were also confirmed by a few independent measurements. But that doesn't mean all of them have been. Radiation was considered a kind of photographic fingerprint of the universe, created when the universe was only 380,000 years old and when it cooled enough for electrons and protons to combine to form neutral atoms. The near-perfect uniformity of the CMB across the entire sky, with small temperature fluctuations, apparently not only confirmed the Big Bang, but also provided crucial information about the composition and evolution of the universe. Everything seemed coherent, and the discovery of the CMB was long regarded as proof of the theory proposed by George Lemaitre. In 1929, Edwin Hubble provided the first direct evidence of the expansion of the universe by observing that galaxies are moving away from us, their speed being proportional to their distance. This observation became known as Hubble's law and was taken as direct evidence of a dynamic and expanding universe. It all fit pretty well into the picture, until the James Webb came along. Now the house of cards of physicists and astronomers is crumbling, and what was long sold to us as truth now appears to be false. If we look at quantum physics, the discrepancies are even greater. Phenomena such as quantum fluctuations in the early universe and indications of the existence of various realities side by side show that the determinism of the old theories is possibly a dead end. It is precisely in this impasse that the scientists whom Neil deGrasse Tyson calls old men now find themselves. It's a tough time for veterans of science, the astrophysicist said in an interview, which means the old ways of thinking won't hold up anymore. James Webb shows us that something was very different in the early universe than previously assumed, and the discussion about the correction of the old standard model of astrophysics has determined that the old theories are no longer tenable. But almost no one wants to say it clearly: we are getting closer to infinity. Although direct evidence for the infinity of the universe or the existence of a multiverse remains elusive, these concepts score points in other aspects of string theory. It is currently the only coherent explanation that can reconcile the world of the smallest particles with the laws of the universe of large-scale phenomena. We're slowly approaching the exact point in time that was supposed to be the beginning, if 13.8 billion years ago, fully formed galaxies were already shining. We know for sure that the Big Bang could not have happened. It's only a matter of time before we can do that. It's possible that James Webb will present more and more images of even older galaxies, and science will get even more clues about what really happened in the universe's past. According to Roger Penrose, there's a certain sense to say that the universe has a purpose. It's not just there by chance. The brilliant physicist Sir Roger Penrose is certain that string theory is wrong and dark matter does not exist. But the problem with string theory is that it's supposed to be a theory about how the world works, and if the number of spatial dimensions is simply wrong, it can't be taken seriously. String theory postulates that the building blocks of the universe are not punctiform particles but one-dimensional strings. These strings vibrate at different frequencies, creating the variety of elementary particles observed. Here I should add that, if we compare the strings with the links of consciousness, then we would be on the right track. String theory was once the acclaimed unification of the four fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces came together here for the first time coherently and in a broader context. String theory practically unites astrophysics with particle physics, but there is a problem. The formulas only work if we assume many dimensions of the four knowns. Roger Penrose opposes this theory, while American Michio Kaku sees it as the only coherent field theory. Penrose is not so concerned with the many of the other dimensions. For the Briton, string theory is unacceptable, despite its mathematical sophistication, because it cannot be empirically tested. Here I want to make a comment. Mathematics is not the language of the universe, and mathematically we are never going to describe what consciousness is. Even on our planet, math doesn't always work and obviously can never be applied to other galaxies or dimensions. Penrose is also critical of a much more significant variable in previous cosmological models. In the debate over dark matter, Penrose also takes a strikingly critical stance that dark matter was practically invented by scientists to explain certain astronomical observations, such as the rotation speeds of galaxies and the effects of gravitational lensing. These phenomena did not coincide with the amount of visible matter in the universe, and thus the theory of invisible dark matter was born. In theory, dark matter is a form of matter that cannot be directly observed, since it does not emit or reflect electromagnetic radiation. Here I should add that, if it does not emit or reflect radiation, it is because our universe is swimming in universal consciousness, and universal consciousness cannot be measured. According to previous models, dark matter makes up a significant portion of the total mass of the universe. Penrose argues that the assumption of an invisible, undetectable substance, which is supposed to make up a large part of the universe, is more of a tentative solution, rather than a well-founded scientific theory. Penrose prefers alternative explanations based on modifying the theory of gravity rather than speculating about the existence of an unknown form of matter. Penrose emphasizes that science should always be open to new ideas and revisions, especially when confronted with the limits of our knowledge. In practical terms, the physicist is saying that we can't base our worldview on assumptions. If scientists don't know something, then they must admit it and get back to the point where knowledge is backed up by observations and solid evidence. On the other hand, modern astrophysics has built an entire world based on the existence of a substance for which there is no evidence. In collaboration with Stephen Hawking, Penrose developed important theories about singularities within the framework of the general theory of relativity. This work has fundamentally changed our understanding of black holes and the origin of the universe. Here I should mention that our scientific community still does not understand that black holes are centers of energy, as I explained in the previous episode, and that the origin of the universe was not the Big Bang. Roger Penrose rejects the idea of a random, purposeless universe, and that's okay because, as I explained, the universe is our physical area to experience. Penrose sees in the complex structure of the universe and in the ultimately fine-tuned laws of physics, evidence of a deeper order and possibly an underlying purpose. The philosophical implications of Penrose's views are far-reaching. If the universe really follows a purpose or has a deeper order, this raises questions about the nature of that order, and the origin of that intentionality could mean that the universe is constructed in such a way that it not only allows, but perhaps even favors, the emergence of life and consciousness. As I have been saying on this channel, the universe is our playground for experiences. This perspective effectively says that our human existence is also intentional for a reason, and our role in the universe could also be much more than just being here. In quantum mechanics, the observer of the universe is equal to the creator of reality. In quantum mechanics, it is often argued that the observer plays a crucial role in determining reality. And it does, as I explained in episodes 5 and 6 about the mechanism of perception, which is the mechanism by which we create our reality. Penrose's studies could show that consciousness and observation are not just passive processes, but active participants in the creation of reality. As I explained on my channel Rewriting the Reality, Penrose's views on the universe challenge conventional cosmology and offer coherent new approaches. Penrose believes that the future of physics is at an exciting tipping point. Theoretical physics could move in an entirely new direction, one that goes far beyond conventional explanatory models of how the universe works. One of these directions could be loop quantum gravity, which attempts to describe gravity within the framework of quantum mechanics, without resorting to extra dimensions or complex string configurations. Other approaches could focus on developing theories based on the holographic principle or postulating entirely new forms of matter and energy, which differ from the traditional notion of dark matter. That is, we should start by recognizing that black holes are energy centers, like chakras, which are the energy centers of our body. All this information that science considers as elementary is not entirely correct, and this is because the scientific community does not yet know what consciousness is and what our perceptual mechanism is. Don't forget to subscribe to this channel.